Wi-Fi often slows down at night because every device nearby is competing for the same limited radio airtime. That is the part people notice first. The useful question is what it tells us about why Wi-Fi slows down when everyone is home and what the system is actually doing. Night shifters. Good evening. I am night shift engineer, checking in from a data center where every blinking light is either routine maintenance or the beginning of a very long night. Let us start simple, then work our way toward the detail the elevator pitch left in the server closet. Wi-Fi rarely slows down because one person did something wrong. It slows down because several systems are trying to share the same patch of air at the same time. The family gets home, the television wakes up, 2 phones start syncing photos, somebody joins a call, and a game console decides tonight is the night for a 40-gigabyte update. The router is still working. It is just hosting a tiny rush hour in a medium where everyone has to be considerate. And yes, the neighbors count. Their routers are using nearby radio channels. Their devices are asking for airtime too. And the walls between houses are much better at stopping conversation than they are at stopping radio completely. The simple version is this. Wi-Fi has limited airtime. Think of airtime as a shared whiteboard. A device gets a brief turn to write, then another device gets a turn. Older Wi-Fi behavior looks a lot like one busy lane, even though the handoffs happen far too quickly for you to see. Newer Wi-Fi can divide and schedule the work more cleverly, but it cannot make a crowded radio channel become an empty one. More devices mean more requests. More requests mean more waiting. And the slow feeling is not just raw download speed. Video calls, games, and web pages notice delay. A connection can have plenty of broadband behind the router and still feel sluggish because the wireless hop inside the house is busy. Wi-Fi is radio, not invisible Ethernet. Your access point sends a frame through the air. A phone or laptop hears it, replies, and the exchange continues in tiny bursts. At the core of ordinary Wi-Fi is a polite rule called carrier sense multiple access with collision avoidance. That name is a mouthful. So picture a room full of people who check whether anyone is speaking before they start. If the room sounds busy, they wait a random moment and try again. That avoids many collisions. It also means a busy room becomes less efficient as more people try to be polite at once. The protocol is doing its job. It is just being asked to run a dinner party in a broom closet. Then there is interference. Your Wi-Fi does not get the room to itself. The 2.4 gigahertz band is especially social. It is used by plenty of Wi-Fi gear, Bluetooth devices, and some household equipment. A microwave does not need to destroy your network to be annoying. A burst of noise near the same frequencies can make a receiver work harder or make devices wait and retry. Neighboring routers can be even more ordinary and more persistent. They are not attacking you. They are simply doing exactly what your router is doing in apartments, townhomes, and houses close enough for their signals to overlap. Radio etiquette works best when the room is quiet. At 6 in the evening, the room is not quiet. Channels are the next part of the puzzle. A channel is a slice of radio space your router uses for its conversation. Wider channels can carry more data when conditions are clean, but they also take up more room and can overlap with more neighbors. The 2.4 band travels relatively well through walls, which is useful right up until every nearby apartment is leaning on the same small collection of channels. 5 and 6 gigahertz usually offer more room and often less crowding, but their signals fade faster through walls and floors. So the best band is not a trophy you win at setup. It is a trade-off between range, interference, device support, and what is physically between the router and the couch where the call keeps freezing. Now add the traffic inside your own house. Every device creates more than the obvious stream. Requests, acknowledgements, retries, cloud sync, app updates, notifications, discovery traffic, and the occasional television deciding it urgently needs new firmware. At the radio level, ordinary Wi-Fi is half duplex. A radio has to take turns transmitting and receiving on a channel. It cannot do both directions at once in the same slice of spectrum. Modern access points can coordinate multiple clients more efficiently, but the shared air rule still matters. Here is the trap most speed tests do not show. Airtime is not the same thing as megabits. A weak or older device may need more time for the same job, then everyone else waits behind it. The router becomes a traffic cop with too many cars and, regrettably, no extra arms. Then physics starts collecting its share. Distance weakens a signal. Walls, floors, plumbing, large appliances, and a crowded room can absorb or obstruct it. Reflections from surfaces create multiple paths between a device and the router. Modern Wi-Fi can sometimes use that complexity well, but in a weak or changing link, it can still make reception harder. A person walking between the phone and the access point can be enough to change the path. That is why a device can be perfectly fine in the kitchen and suddenly miserable in the back bedroom. More errors mean more retries. More retries consume airtime. Physics is undefeated, and it has never accepted a support ticket from a router positioned behind a television. The router itself can also become the limit. A lot of older or provider-supplied gear was selected for a modest home and a modest number of active clients, not for several simultaneous streams, video calls, gaming, backups, cameras, and a small army of smart devices. The radio has to schedule clients. The processor has to handle routing, encryption, network address translation, and sometimes security features. Memory has to hold queues. None of that means every inexpensive router is bad. And it definitely does not mean your house contains a miniature data center. But a busy home can ask more of its access point than its placement, processor, or radios were designed to handle. At that point, replacing the hardware can help, but only after you check whether the actual bottleneck is Wi-Fi, the broadband link, or the game update that chose violence. And then there are the neighbors. Your network does not stop at your front door. Its radio energy leaks into the same local air as nearby networks, and theirs leaks back. When more households become active in the evening, there is simply more traffic competing in nearby channels. Routers do not need to turn up their power for this to matter. They only need to use overlapping or adjacent radio space, especially in the dense 2.4 gigahertz environment. Devices may wait longer, pick up more interference, or need retransmissions. None of those networks is doing anything malicious. They're all trying to stream dinner television, backup photos, and update a thermostat at the same time. The invisible neighborhood rush hour is real. You just cannot hear the engines. This is where the failure modes become visible. Two devices can sometimes transmit at once, especially with newer multi-user features, but ordinary contention and hidden nodes can still produce interference or a failed frame at the access point. Devices then back off for a random delay and retry. Weak links can trigger retransmissions and rate adaptation, where Wi-Fi intentionally chooses a slower, more reliable radio mode instead of pretending a bad signal is fine. And some painful delay may be downstream of Wi-Fi entirely. A crowded gateway or internet connection can build long queues, a problem often called buffer bloat. The symptom is the same. A call stutters while a download runs, but the fix is different. Your Wi-Fi is not necessarily broken. It may be overwhelmed, poorly placed, sharing a crowded channel, or waiting behind a queue somewhere else in the chain. So what actually helps? Start with placement. Put the access point high and as central as practical, out in the open, not inside a cabinet behind a television. Use 5 or 6 gigahertz for nearby capable devices when it makes sense, and leave 2.4 for long-range or low-demand gear. Wire the stationary heavy hitters when you can, a desktop, console, streaming box, or mesh backhaul. That removes traffic from the shared air instead of asking the router to perform better manners. If coverage is the issue, a well-placed additional access point with wired backhaul is usually cleaner than hoping one heroic router can negotiate 3 floors of drywall. In the data center, we call this capacity planning. At home, it is moving the router before blaming the router. Wi-Fi 6, 6E, and 7 improve the toolkit. They can schedule traffic more efficiently, use additional spectrum where available, and handle many compatible devices with less waste. Useful progress, not magic. A new router cannot repair a weak signal through concrete. erase a neighbor's radio activity, or turn an overloaded broadband connection into a faster plan. My night shift verdict: Wi-Fi slows down when everyone is home because it is polite, crowded, and governed by physics that do not scale just because the house acquired 6 more connected objects. Find the constrained resource, airtime, coverage, channel crowding, router capacity, or broadband queue, and the problem stops looking mysterious. What part of your own setup has been quietly causing trouble? I have seen data center incidents with less drama than a family trying to stream 4 things during a firmware update. So, night shifters, bring it back to the system, not just the surface. Keep the confirmed mechanics, name the trade-offs, and leave room for the unknowns. What part of this system surprised you the most? If you want clear explanations of the systems around us, you know where to find me. Stay caffeinated. Stay curious. I need to go tend to a coolant alarm in row 7 that has apparently developed opinions. Night shift engineer out.